This is Unit 1, Topic 10, Qualitative Tests. There are 5 things you need to know for this. So the first is the chemical test for the gases hydrogen, oxygen, chlorine, carbon dioxide, HCl and NH3. Then demonstrate an understanding of how to carry out a flame test using nichrome wire. The cation tests, so flame test to identify the ions of lithium, sodium, potassium, calcium, barium and copper. And then adding sodium hydroxide solution and warming to identify the ammonium ion. The anion tests, including barium chloride solution to identify a sulfate ion, acidified silver nitrate solution to distinguish between chloride, bromide and iodide, followed by adding dilute and concentrated ammonia solution, and adding dilute acid to test for carbonate ion and identifying the gas produced, and finally the use of starch to identify iodine. So quantitative analysis is the process of determining information about a chemical species, including its identity, in a non-numerical fashion, and there are a series of diagnostic tests which can be used to identify gases, cations, anions and elements. We look first at the gas tests. So for hydrogen, we know that we apply a burning splint and we get a squeaky pop. For oxygen, it's a glowing splint and it relights. For chlorine gas, it's damp blue litmus, and the litmus paper or universal indicator paper turns red and is then bleached white. So for carbon dioxide, CO2, we bubble the gas through lime water and we get a milky precipitate due to the formation of insoluble calcium carbonate. Prolonged exposure leads to formation of a colourless solution as the calcium carbonate precipitate reacts to form soluble sodium hydrogen carbonate. Hydrogen chloride gas, HCl, you expose a glass rod dipped in concentrated ammonia solution to a stopper from the bottle of concentrated ammonia, and you get white fumes or smoke or a solid, which is ammonium chloride. The test for ammonia gas, NH3, is the same but the other way around. So it's a glass rod or a stopper from a bottle of concentrated hydrochloric acid will give you white fumes or smoke or solid, which is ammonium chloride. So our cation tests then. A number of metal cations can be identified by a flame test. So the method is as follows. You take a piece of nichrome wire, dip it into concentrated hydrochloric acid and then into the sample. Then you place in the blue Bunsen burner flame and record the colour observed. So for lithium, that would be crimson. For sodium, it's yellow/orange. For potassium, it's lilac, and you could also say that it's pink if viewed through cobalt glass. Calcium is brick red or red. Copper is blue-green or green-blue, and note that we use a hyphen to describe that colour. And barium is green or apple green. The ammonium ion can be identified by warming with a solution of sodium hydroxide. A pungent smell is observed and the gas produced gives the white fumes with a rod dipped in concentrated hydrochloric acid. The anion tests then. For the sulfate ion, we add a solution. We add to the solution a few drops of barium chloride or barium nitrate solution, and we get a white precipitate of barium sulfate. And the equation for that is Ba2 plus SO42 minus gives us BaSO4. The halide ions for chloride, bromide and iodide, we're adding dilute nitric acid to a solution of the halide followed by a few drops of silver nitrate solution. So for chloride we get a white precipitate. For bromide it is cream, and for iodide it is yellow. And it should also be noted that the precipitate of silver chloride dissolves in dilute ammonia. Silver bromide dissolves in concentrated ammonia, but silver iodide does not dissolve in dilute or concentrated ammonia. And if you're asked for an equation, we have Ag plus Cl minus gives us AgCl. For the carbonate ion, you're adding dilute hydrochloric acid and then you bubble the gas produced through colourless lime water, and the lime water turns milky because carbon dioxide is evolved. The test for iodine then is that the addition of aqueous starch to iodine solution results in the formation of a blue-black or black-blue solution.